Hello everyone. So today I am starting uh, module 1 and this is our lecture number 1.1. That means first lecture, module 1 first lecture. Okay, so first of all let's discuss the syllabus of module 1 and this is linear algebra. The spelling is mistake. Linear algebra. Okay, so first one is echelon form and normal form, then matrix inverse and their rank, consistency and inconsistency system of linear equations, solution of the linear system of equations, and eigenvalues, eigenvectors, diagonalization, and last one is Cayley-Hamilton theorem. Okay, so in first lecture I am starting from your first topic, that is echelon form. Okay, and basically in your syllabus the topic is row echelon form. So to understand what is echelon form, first of all we have to know that there are some elementary row operations in matrix. Okay, so our first topic is elementary row operation. Elementary row operations. Actually in class 11 or 12 you have learned that row operation, column operation and so on. But whenever you are solving a system of equation, you cannot apply column operation. Okay, so row operation is very important and in your syllabus only row operation is included. Okay, so our discussion is totally depending on row operation. We will never discuss about column operation. Okay, so when we are operating on row, we can apply three types of operations. Only three types of operations, and these three types of operations are called elementary row operation. First one is we can interchange two rows. Okay, that is called interchanging. Okay, so first operation is interchanging. That means we can interchange between two row, Ri interchange Rj. Okay, second operation is scalar multiply. Scalar multiply means we can multiply any row by scalar. Okay, let's say I am changing ri dash, this is equals to, let's say k is any scalar number, k into ri. Okay, so this is two types of elementary row operation. And the last one is linear combination. Linear combination means you can change a row by applying addition or subtraction with scalar multiplication. So ri dash, this is equals to, let's say ri plus krj. Remember, when I am changing the ith row ri, you cannot multiply any scalar on that particular row. Okay, in case number 3, that means linear combination, you are changing the ith row. So remember, you cannot multiply any scalar number on that particular row. Okay, you have to multiply on the second row with which you are changing this row. Clear? So we have three types of row operations. First one is interchanging, second one is scalar multiply, and third one is linear combination. Okay, or you can say linear operation. Okay, first one is ri interchanging rj, second one ri dash equals to kri, and third one is ri dash equals to ri plus krj. And what are ij? Ij denotes the number of rows or columns. Okay, or the position of rows or columns. Okay, now your topic is row equivalent or echelon matrix. So let's understand what is echelon matrix. Echelon matrix. Now, so suppose we are given a matrix A. Okay, we are given a matrix A and we have to convert this matrix to B using row operation. using row operations, we have to convert the matrix A to the matrix B, and this matrix will be called row echelon matrix. This matrix will be called row echelon matrix if first condition is during this operation all the zero row will be at the bottom of the matrix. Clear? All the zero rows, actually sometimes you can say that there is no zero row, that's why I am writing if any. So all the zero rows, if any, are at the bottom of the matrix. Clear? So if there is any zero row during this operation, that zero row must be at the bottom of the matrix. Okay, that means you have to interchange the matrix. Number 2, interchange the row. Number 2, each pivot element and now question is, what is pivot element? Let me explain it. So first of all, let me write this statement. Each pivot element in a row is to the right of the pivot element in the preceding row. Okay, so this is the basic concept of row echelon matrix. First one is all the zero rows will be at the bottom, and second one is each pivot element. Now what is pivot element? Pivot element means the first non-zero element in each row. First non-zero element in each row. Okay, the pivot element in a row is to the right of the pivot element in the preceding row. Okay, so let me explain this. Suppose we have a matrix 1, I am writing the row echelon form 1 0 2 1, let's say 0 1 3 1 0 0 1 2. Okay, now in this matrix you can see in first row 1 is the first non-zero element. In second row here 1 is the first non-zero element, and in third row here 1 is the first non-zero element. Okay, so for first row this one is our pivot element, for second row this one is our pivot element, and for third row this one is our pivot element. Okay, and it is saying that in a row, let's say I am taking the third row, in a row the pivot element must be to the right of the preceding row. So obviously this one is pivot element, and this is our second row pivot element, and this is on the right side. That means in opposite sense it is saying that all the elements below the pivot element must be zero element. Okay, all the elements below the pivot element must be zero element. So in simple language what we can say, first one is all zero rows will be at the bottom. Okay, now I am writing my own language, not any book's language. So all zero rows will be at the bottom. Second row will be all the elements below the pivot elements must be 0. Okay, so all 0 rows will be at the bottom and all the elements below the pivot element must be 0. Sometimes many students have asked me that sir, is it necessary that the first non-zero element must be 1? No, this is not necessary. In echelon form, the first non-zero element may be any number, any real number. Okay, it not necessary that that will be 1. Okay, now let's say I am taking an example. Suppose I am writing a matrix 2 1 8 0 0 0 0 0 0 1 2 minus 2 0 0 9 0. Okay, this is first matrix. Now I am taking another matrix 1 2 3 1 0 0 0 1 0 0 0 0. Okay, taking another matrix 2 1 8 2 0 1 2 minus 2 0 0 9 0 0 0 0 0. So here I have 3 matrices. You have to tell me which one is in row echelon form and which one is not in row echelon form. Okay, now first one. Here in first matrix you can see that 0 row is on the second position, but the condition is 0 row must be at the bottom. So obviously this is not in row echelon form. Yes or no? Okay, now second matrix. Second matrix, is it in row echelon form or is it row echelon matrix? No. Why? Because in first row we have pivot element. Okay, condition is all the elements below the pivot element must be 0, but here we have a non-zero element below the pivot element, so this is not row echelon form. Okay, now last one. Here we can see that the 0 row is at the bottom. Okay, and 2 is pivot element, 1 is pivot element, 9 is pivot element, and below the first pivot element all the elements are 0. Below the second pivot element all the elements are 0. Below the third pivot element all the elements are 0. Okay, so obviously this matrix is in row echelon form. Clear? Now there is a huge application of row echelon form. Using this row echelon concept you can easily find out the rank of the matrix. Okay, you can easily find out the rank of the matrix. How? Rank of the matrix means the suppose we are given a matrix A, and first step is you have to convert the matrix A to the matrix B, and this matrix is in row echelon form. Row echelon form. Now in this row echelon form or in this row echelon matrix, number of pivot element represents the rank of the given matrix, rank of A. Okay, the number of pivot element in B imply rank of A. Okay, so you will be given a matrix A. First of all you have to convert the matrix A to its row echelon form, then find out the number of pivot elements. Okay, and that particular number will be your rank of the given matrix. Clear? Let's take an example question. Reduce the matrix A is equals to 1 2 minus 2 3 2 5 minus 4 6 minus 1 minus 3 2 minus 2, 2, 4, minus 1, 6. Okay, we are given this matrix. So reduce the matrix this to an equivalent echelon matrix. To an equivalent echelon matrix. Okay, hence find the rank. Okay, here I am getting a one mathematical word, that is equivalent. Equivalent means here the original matrix and the row reduced matrix of the matrix are always equivalent. Okay, that means the solution of this matrix and the solution of the echelon matrix will be always same. That's why we can use the term equivalent. Okay, now so let's solve this question. We have to apply the row operations, and we have only 3 row operations. Okay, so first 1 2 minus 2 3, 2 5 minus 4 6, minus 1 minus 3 2 minus 2, 2 4 minus 1 6. So first we can apply R2 minus 2 R1, R3 plus R1, and the last one is R4 minus 2 R1. Clear? So this is equals to 1 2 minus 2 3, then 0 1 0 0, 0 minus 1 0 1. Okay, R3 plus R1, so yes, and the last one is R4 minus 2 R1, so this will be 0 0 minus plus 3 0. Clear? Now next we can apply, next operation is R2, actually R2 na, R3 plus R4, sorry, R3 plus R2. Next operation R3 plus R2. So first row 1 2 minus 2 3, 1 2 minus 2 3. Second row 0 1 0 0, 0 1 0 0. Third row now R2 R3 plus R2, so this will be 0 0 0 1, 0 0 0 1. Okay, and the last one 0 0 3 0, 0 0 3 0. Okay, now is this matrix in row echelon form? Yes or no? Think yourself. Is this matrix in row echelon form? Here in first row this is our pivot element, in second row this is our pivot element, okay, third row this is our pivot element, okay, and in fourth row this is our pivot element. But again let's take a look on the conditions. Here given that each pivot element in a row is to the right of the pivot element in the preceding row. So this pivot element 3 must be on the right hand side of the previous pivot element. Previous pivot element is 1, but this pivot element is on the left hand side. Yes or no? That means now we have to interchange the last two rows R3 and R4. Okay, so from here R3 interchange R4, so we are getting 1 2 minus 2 3, 0 1 0 0, 0 0 3 0, and the last one 0 0 0 1. Now it's completely in row echelon form. Okay, and which one are the pivot elements? This 1 1 3 and 1. Okay, so this is in row echelon form. This is our B matrix. And what is the rank of this matrix? Rank means number of pivot elements. So rank of A, this is equals to 4. Clear? Rank of A, this is equals to 4. Let's solve another question. Next question. Find the rank of the following matrix. Find the rank of the following matrix using elementary row operation. Row operations. A is equals to 2 3 minus 1 1 3 0 4 2 6 9 minus 3 3. Okay, very simple. First convert this matrix in row echelon form. Solution. So 2 3 minus 1 1 3 0 4 2 6 9 minus 3 3. So first operation, we can change R2. So R2 minus 3 by 2 R1, and similarly R3 minus 3 R1. So this is equals to 2 3 minus 1 1 and 3 by 2. So first this will be 0 minus 9 by 2 and 4 minus minus plus 4 plus 3 by 2, that means 11 by 2. Okay, and the last one is 2 minus 3 by 2, that means 1 by 2, and the last row is 3R1. So this will be 0 0 0 0. Okay. Okay, is it in row echelon form? Obviously yes, because last row is on the at the bottom. Here we are getting pivot element at the first row and pivot element at the second row, and all the rows below the pivot element are 0 row. So obviously this is in row echelon form. Now you can find out the rank. Rank of A equals to number of pivot, and this is equals to 2. Clear? So in this way you can solve this type of problems. Now remember one thing for regarding this rank concept. Remember rank, tell me, suppose we have a matrix 0 0 0 0 0 0 0 0 0 0 0 0. What will be the rank of this matrix? This is 0 matrix, na? So remember, rank of a 0 matrix, rank of 0 matrix is 0, and this is the only matrix of which rank is 0. Okay, rank of a non-zero matrix will be at least 1. Okay, remember one more point, rank of A is always equal to its transpose, rank of A transpose. Okay, rank of A is always equal to its transpose. Now suppose here we can calculate rank for every square matrix as well as rectangular matrix. Now suppose we have a matrix A, square matrix n by n, okay, square matrix. Okay, now question is you have given a matrix A, square matrix. Now they are asking that the rank will be let's take an example. Suppose A is equals to 3 by 3 matrix, obviously square matrix, and you are given 4 options that rank of A equals to 3, option B rank of A greater than 3, option C rank of A let's say less than 3, and option D rank of A equals to 0. 4 options. Okay, so rank of A equals to 0, this is not possible, because it is possible only when the matrix is 0 matrix. Okay, let's say I am taking it is non-zero matrix, non-zero matrix A. So rank of A equals to 0, this is not possible because it is possible only for 0 matrix. Okay, now second case, rank of A greater than 3, this is not possible because rank of a matrix can never be greater than the order of the matrix. Okay, rank of a matrix can never be greater than the order of the matrix. So option B is also incorrect. Okay, now you have 2 options, rank of A equals to 3 or rank of A less than 3. So short trick is, if the matrix is square matrix, then easily we can find out the determinant. So find out determinant. If determinant is not equals to 0, this implies rank is full rank, that means 3. Okay, if determinant is less than 0, then rank will be less than 3. Okay, but remember, this method is not for every matrices. It is possible only for square matrices. And also, using the determinant concept, you cannot say the exact rank. Okay, if the determinant is 0, sorry, this is not less than 0, this is equals to 0. If the determinant is equals to 0, you can say that the rank will be less than the order of the matrix, but you cannot say the exact rank. Okay, and if the determinant is not equals to 0, you can say the rank of the matrix will be full rank. Okay, so obviously if A is n by n square matrix and determinant A is not equals to 0, this implies rank of A is equals to n. And if determinant A is equals to 0, so obviously rank of A is less than n. Clear? Now, right now I have told you that rank of a matrix cannot be greater than the order of the matrix. Yes or no? Now suppose we have a matrix A and the order of the matrix is m by n. Okay, so here you have an important result, that rank of A that will be less than equals to minimum of m comma n. That means, suppose we have a matrix A of order 2 by 3, then the rank of this matrix A that will be less than equals to 2. Why? Because here the condition is rank of A is less than equals to minimum of mn. Here between m and n, m is equals to 2, n equals to 3. So between m and n, which one is minimum? Obviously 2. So rank of A will be less than or equals to 2. Okay, this is very important and very powerful result on rank. Okay, now you try your textbook problems and try your question bank also. If you have any doubts, you can ask me in comment section or on my WhatsApp number also. Thank you.